My dear students, today we are going to discuss the third chapter in class 12, which is dealing with current electricity. A section is there, Kirchhoff's loop rule, which is also the Kirchhoff's second law, which is termed otherwise the mesh rule. What is this loop? The term loop means something which will begin at a point and traveling through a certain route, it will come to the same point. That's the loop. Mesh, we have seen fishing nets, no? In that each and every loop, each and every single cross lines, when it is joined together to form a loop, no? Somewhat like it will come like this. Consists of the fishing net consists of lots and lots of squares, which can be lengthened and also heightened. So the mesh and the loop and the second law are all the same. What is this related to the electrical circuit? The loop is there like this in the electrical circuit. This is the loop. The first loop, the second loop, and the bigger third loop. It is given by a nomenclature A, B, C, D, H, A. The first loop, A, G, F, E, D, B, A. The second loop, and A, G, F, E, D, H, A. That is the third loop. So, coming to the second law, the Ncert definition, which says in an electrical closed loop circuit, this is an electrical circuit which is closed, the algebraic sum of the changes in potential around any closed loop. The algebraic sum, that means it is added together the changes in potential. What are all potential differences over here, anywhere with a resistance and the current flowing through it. All the sum of all, the algebraic sum of all the changes in potential around any closed loop involving this resistance and cells is 0. When we calculate all these potential changes, then it will become 0. Or the definition can be said in otherwise, in any closed circuit, the algebraic sum of the product of the current and resistances. In a closed circuit, the product of current and resistance for various branches. Various branches are there now, 1, 2, 3. Over all these branches, the product of the current and resistances of these various branches is equal to algebraic sum of the EMF of that closed circuit. Whatever all circuit we take, there will be an EMF provider. That is the product of the current and resistance will be equal to this EMF provider. That means the EMF of that circuit, which is provided by the cell. When we come to the problems, I will make it clear what all it is said in these sentences. That first of all, you must just by heart, so that you could write in the exam, that the algebraic sum of the changes in potential around a closed loop involving resistance and cells is 0. Second of all, the product of current and resistances is equal to EMF of that closed circuit. When going to this circuit diagram, at a point, the I3 current is divided into two sections. That means it is the first rule, the junction rule, the point rule. Then this I3 is equal to I1 plus I2. At D point, this I1 and I2 will constitute this I3. I1, I2 gives I3, and this I1 plus I2 gives this I3, which is written. Note that this is in the page 116, figure 3.22 Ncert text. And while solving the problems of this question, there is a sign convention is there. What are all circuits we choose, when the circuit starts from the positive to the negative point, then take the battery voltage, which is over here, to be positive. When it is positive to negative, then it's positive. When it is negative to positive, then it is negative. So note it in your mind, and we can just go to the problem section. AHDCBA is our first loop. A H A H D C B A. This is the first loop. The current is flowing from positive to the negative. Positive terminal of the battery, 45 watt, to the negative terminal of the battery. Okay, first of all, we want to take a current direction. Okay, consider in the text is given that let take a current direction. That means it should be, okay, I1 is taken as negative. This current flow is taken as negative. We can solve it afterwards. First of all, we will use a convention. That means, okay, take this, which is from the positive side, as negative I1 into this resistance encountered, 30 ohm, minus I3. That means this I3 current, which is passing from here into the 1 ohm, which is encountered over here. This is the 1 ohm. The same direction, it is encountering 40 ohm. That means the same I3 current is encountering 40 ohm over here. Then the loop is complete. Then that is added to the battery voltage. I have earlier said no, positive to negative. Then it is taken as positive. This is written over here. So we can simplify all this. Minus I3, taking it out common. 40 plus 1, 41. That means negative 30I1 minus 41I3 is equal to this plus 41 on the other side gets minus 45. When we look at this, all things are negative. Multiplying the whole thing into negative. Then minus into minus plus, minus into minus plus, minus into minus plus. That means 30I plus 41I3 is equal to plus 45 volt. This is the explanation of the Ncert text of this loop. Take the next loop, AHDEFGA loop. The next loop is AHDEFGA. Oh, this is the larger one, no? So, what is the cell encounter? This negative to positive. Then we will give this negative sign over here. So, starting from the minus I1. Okay, minus I1, that I1 is taken as negative convention. This minus I1 into 30 ohm. Then it is encountering another current from here. When it is going to here, when it is entering here, the junction, this is encountered by the I2 current, which is in the opposite direction. So it should be given the plus sign, plus I2, which is encountering a resistance of 20 ohm. This is a 20 ohm. Then the same I2 was encountered by the resistance 1 ohm. This is given over here. And this loop is completed over here, the junction. Okay, starting from here, the loop is completed. Then it is written over here like this, and we can simplify. Minus 30 I1 plus 20 plus 1 into I2 minus 80 volt is equal to 0. This is the textual answer. So, it is not given in the text, but can I choose for your knowledge that if along F, E, D, H, A, G, F, F, E, D, H, A, G, F, that means in this anti-clockwise direction, what all it is encountering? The cell GF, positive to negative. Then first of all you must write the positive 80 watt, which is providing the EMF. No. Then the I2 current FE. Okay, I2 into the 1 ohm encountered, 20 into I2 into 1 ohm, the FE section, I2 into 1 ohm. Then the ED section, I2 into 20 ohm. Then the I1 is coming in the opposite direction, minus I1. Okay, minus I1 into this encountering 30 ohm plus 80, the voltage of the EMF. The voltage given, the EMF of the cell. Okay, this all is added together to give 0. That is the second law. So, simplifying all this, we can get a very cute answer. So, this is enough for you. I will encounter another problems. I will explain to it. Then you will be well versed in all that. Okay, when we consider, don't be confused by the loop word, because we consider equator is also a loop which is circling the earth. When we start from one point in the equator, when we go around the earth, it will come back to the same point. Hence, this rule is named like this, the loop rule. The mesh, when it starts from one point, then it will return to the same point in a mesh. That's it, second law. Okay, when encountering other big problems, you just simplify these loops into simpler circuits. I simplify into 3 circuits now. 1, 2, and 3 circuit. I simplified the loops. Convenient naming. You should give a name now. I3, I1, I2, that thing. And also the sign conventions also. Uncomplicate the symmetry by drawing conveniently. If you want to solve the problem without looking at this picture, draw straight away, take outside this loop, draw another picture of the same thing to the next, below this, and just do the calculation. It will make it so easy. So we will see in the next class. If you have any doubt, please call me. Please share, subscribe my channel. Please follow me. Study well what I'm teaching. I'll be back with more ideas.